Hi, I'm Rich with insideHPC, and we're here at the Altair Technology Conference in Garden Grove, California. And I'm here with Clifford from Cray. Now, Greg, you and I worked together many years ago at the old Cray research. But
many years ago.
Many years ago. Gosh, too many. I wanted to start at the beginning, though. Who is Cray today, and who do you help?
Yeah, so Cray is focused on the high end of the HPC marketplace. And so when I say high end, I mean talking in dollar standpoint, it's $500,000 on up. And our particular focus is companies, whether it's a one chassis or one cabinet machine or a 200 cabinet machine, it's people who are doing production HPC simulation. So not research projects, but this is work that's mission critical to their organization, and they need a machine that scales well, it's reliable, and is going to deliver on time.
Okay, so they're going to base their business on it. They're not going to just cobble something together. They go to Cray for that.
I mean, for our whole legacy, right? People know Cray from years ago. It's always been high performance computing, and especially at the higher end of the marketplace. Mm-hmm. But that higher end of the marketplace could be a mid-sized company doing consulting, or it could be a Fortune 1 company,
sure.
Where HPC is critical to their simulation.
Yeah. So on that note, I remember back, Altair was one of the first smaller companies that bought a Cray when the company introduced a desk-side Cray. Something 1993, the Cray EL.
Yep.
And I wanted to ask you, what's changed in that space? I mean, that was a vector machine, but what's changed in CAE in those 20 years?
Well, from the hardware side, of course, it's changed dramatically. As you mentioned, from the vector machines, it eventually moved into more parallel SMP, shared memory parallel environments, then migrated to distributed memory parallel, where now you're talking about hundreds of cores. Well, today on the hardware side, it's thousands of cores, and really tens of thousands, even on our higher end systems, hundreds of thousands of cores. Many people in the CAE space, automotive companies, aerospace companies, have on the order of 50,000, 100,000 compute cores in their environment. So needless to say, the amount of compute power has changed dramatically, and I think that reflects the importance of CAE in these organizations. Whereas before it was a played a role, somewhat of a maybe after the design, decisions were made to verify things. Now CAE is critical throughout the whole design process, and not just the design process, but the manufacturing process, even going to market. So the application codes, for example, Radius has been around really for that whole time frame. The name is still there, but they also have changed quite a bit technology-wise, and that they're able, they aren't targeted for machines with, 4 processors or 8 processors like that early Cray was, but rather for machines that do have 800, 8,000, 80,000 compute cores in them. And so it's been really a dramatic change across the board.
Yeah, and as we're seeing this in your talk today, I thought this was fascinating. You said it's not unusual for today's, maybe even a subsidiary of a company, to have 10,000 cores on site. But the gap that you pointed out was that most of the jobs are running at 250 cores or less. So what's causing that, and what's the remedy?
Well, there's lots of factors. Some of it is non-technical issues, or what I'll call maybe not core technical issues, where it's change, right? The organization is set up to run jobs at a certain size. People build their models to fit that size and that level of turnaround. So there's a certain inertia that has to be overcome there. And also, I think just education, that people have the perception that, yes, in the national laboratories, they can run a job that scales to 1,000 cores, but that's not CAE applications, and ISV applications don't really scale that well. And I think that's a perception that is holding people back and is not particularly accurate. That there's been a lot of work done by Altair engineering to improve the scalability and take advantage of the really massively parallel and highly scalable hardware systems that are out there today. So that's one big thing, is just educating the people of what's possible with today's technology.
Yeah. Well, I guess one of the users after your talk, I thought it was interesting. He said, "Well, if I do run a job that size," he goes, "it takes days to deal with the data," and that's another factor because you're not going to let that sit on the machine, are you? I mean, for scratch, so other people need to do work.
Yeah, I'm glad you mentioned that
Yeah.
because that it's I'm kind of focused in this particular discussion on the number of cores and the CPU performance.
Right.
But you have to address the entire environment, from the model building generation and technology required to build these large models, the visualization capability to analyze the results, and it goes without saying that when you're running a job on thousands of cores and getting that level of performance, you're generating data 10 times faster as well. And this whole, as the industry calls the big data problem,
Sure.
it's extremely important CAE as well. And to be frank, I've just recently seen some feedback on this that it's somewhat out of control, that huge volumes of data are being generated. People are storing it away because they aren't quite sure what to do with it. And I think that's going to be one of the next technologies that'll make an impact here, is how to not just organize and manage that data, but how to leverage the data and analyze the data for new insights into what the simulation shows you. So that's a very important topic, and one that more to come, so to speak, in that area.
Well, this is an area where Cray has started to specialize with this initiative.
Absolutely,
right?
Both in terms of the fast data, where you're able to be able to write the data and read the data quickly, because that certainly can become a bottleneck, and also the more sophisticated data analytics capabilities. Doing graph analysis. One of the things we say is it's not just when you looking for an answer to a question, it's looking for an answer when you don't know what the answer is, but you also don't really know what the question is, right? And going to the data and trying to find these relationships and insights that you just cannot see, because of the volume and the complexity of the search that's involved.
Well, great. Well, hey, Greg, I want to thank you for coming on today. This has been fascinating.
Oh, thank you.
And I want to point people to your talk today, because that was really good stuff.
Well, I appreciate it.